Okay, so this is the guitar string lab, and if you could turn to page 31 in the lab portion of the workbook, and let me just describe your data collection and what you're going to be doing in this lab. Okay, so on page 31, so this is where you're going to record your data that you're going to collect, your measurements, and then your calculations. So if you look on the left side, so we're going to use a set of 6 guitar strings, the 6 strings that are typically put on a guitar, and they're identified on the left hand side, they're identified by color, string letter, and string number. We're going to be concerned mostly with string number because I've got them identified that way, and then also color. You'll be using color to identify them as well. This is just colors that the manufacturer of the strings assign to the strings. You also have string diameter. We're not going to use that at all in your in this lab, and then also the string letters. We're not going to use those at all. All right, so you have a place to record string length that you're going to measure, and that's in meters. You can see the top of the column. Okay, and then you've also got string mass in grams, which you then will need to convert over into kilograms. You also have string tension in pounds. This is how much tension there would be on the strings when they're tuned properly. And where we got that was from the package. So this is on your page 33 in the workbook. I've given you a copy of the packaging for these strings. And these strings were selected because the manufacturer also elects to share the tension in the string. So we've got tension in the string in pounds and kilograms here, and so we can actually use those. That'll end up being our capital F term in your frequency equation. And also we've got down here at the bottom of the table, you've got, or about bottom of the packaging, you've got 25.5 inches. So what the manufacturer is saying is that they're just using arbitrarily a string length of 25.5 inches as when they're mounted on the guitar. Okay, so back to your table. So you're going to be converting the string tension in pounds to newtons. You'll find a conversion between pounds and newtons in your conversion chart. Then you're going to calculate the frequency of the fundamental frequency for n equals 1, and then once you have n equals 1, then you'll calculate the third overtone. You'll have to figure out the n value for that and calculate the frequency there. Also at the bottom of the page you'll see that the capital L, again from the packaging, is 25.5 inches, but you'll have to convert that to meters in order to use it in your equation. So you can just do that conversion down here and make sure you use that in your calculation for capital L. And then there also on page 32 are some questions, and so you'll be answering those as well. The other page of interest is your page, if you can look at page 34. Page 34 just gives you a little more information, which is showing you how the string is placed on the guitar from a bridge to another bridge, and those are the two fixed endpoints, and a standing wave will be created between those two fixed endpoints. And then, for instance, the grommet that we're not really including in all this, that's what kind of gets anchored down in this area, and then the tensioning occurs over here. And this last sketch at the bottom, that's just reiterating what I already which I will tell you probably later when I show you the measuring, is when you measure the lowercase l, you're not going to include the grommet and the winding. You're just going to go from the end of this winding in here to the end of the string to get your lowercase l. Okay. if in my absence you have any questions and you don't finish the lab, that's okay. You can ask me the next time you see me. And I'll also provide you with the frequency for your first calculation, because I typically would always check your calculation of your first frequency to make sure you're on the right track. So you'll be provided with that just so you can make sure you're doing the calculation properly. All right, next I'll show you how to do the actual measurements of mass and length. So one of your measurements will be the mass of each string, and that'll be in grams. So we'll have the scale set up in the back of the room, and with each of the 6 strings laid out. So as an example, here is the number 6 string with the brass color. Now the grommet and the winding at the end of the string have been cut off because we're not including that in the mass. That's not part of the vibrating string. So the string is just wound up. Just take the string as it's presented to you, and then place it on the scale and get the mass in grams. Make sure that you re-zero the scale first, because it might have drifted, and then also make sure you write down everything that the scale is displaying, and again make sure you're in gram mode, since there are 3 other units that can be displayed by this scale. Alright, and then also just make sure you record your masses in the correct location on your table. So we have strings 1 through 6 laid out here, and they're labeled with both the number and the color. Another measurement you'll be making is the length of the strings. So they're laid out on the table, and you have a meter stick here. All of the strings will be a little bit less than a meter, so 1 meter stick will be fine. Let me describe, though, how you're going to do this. Now, in this case, the grommets on the end of each string are still there. That's for identification purposes, so you make sure that you know the identification of the string you're measuring. So I'm just going to demonstrate here for you one of the measurements. Now I have this particular string, I believe this is the number 6 string, taped down to the meter stick, and that's only because I only have 2 hands and I need 1 to hold the camera. So you're not going to be taping the string to the meter stick. You can just lay it out like this. However, what you'll notice is I'm not measuring to the end of the grommet. I'm measuring to starting at the winding that winds the grommet onto the string. So you can clearly see it. Like for instance, here's another one where the winding which is used to wind the grommet onto the string, it ends in here. You can visually see it. So don't include that in your measurement. And then at the other end, you can just go to the nearest millimeter. So this measurement to me looks like about 98.5 centimeters, but I believe on your data sheet on your table you're going to record that in meters. So that would be all the way to the end would be 1 meter. So in this case you're at 0.985. This is 90 right here, 98 centimeters. So you're 0.985 meters. So that's how you'll record it in your table. And I also would want to make sure that all the lab groups take their own measurements. You're not going to be sharing measurements between groups. So each group is going to individually collect their own mass measurements and length measurements. Okay, so when you're ready, you can start calculating the frequencies, which are the 2 rows on the right of your table. So I just wanted to provide you with the first answer just so you can check to make sure you're on track. So you'll be using this frequency equation. So the first one you should calculate is the fundamental frequency for string number 1, silver. And here's approximately what you should be getting for n equals 1, about 329 hertz. Now your calculation might be different than that slightly because your mass and your measured mass and your measured length might be slightly different from what I got. So don't panic if you don't have exactly 329 hertz. You might be a little more than that, you might be a little bit less than that. But just check that first, because if you're making a mistake on your calculation with the first one, then you might be repeating the same mistake with all the other ones. Okay.